Hello again, everyone. So today I'm sitting here in front of my Pentium Overdrive 83 megahertz machine that I've used a few times in the past for playing games. And I wanted to do a video on DOS memory managers, DOS memory management. And I figured this would be a great computer to do it on because I'm running all three. Well, I have a config for all three memory managers, three of the more popular ones. The standard HiMem and EMM386 that come with DOS and Windows, QEMM from QuarterDeck, and Netroom from, I think it's Network Associates. Well, it was Helix originally. And that's the version I have, the version that was from Helix. So, real quick, starting at the very beginning, we of course have conventional memory that everyone knows is the 640 kilobytes of memory limit for the original IBM 8086. Now, of course, legend has it that Bill Gates said 640K ought to be enough for anyone, but he didn't actually say that. If you follow a Google search or any decent search on that, it was made up by a journalist at a magazine. It was a made up interview that never actually happened. In truth, as I understand it, Bill Gates knew, and I'm not trying to glorify Bill here, don't really care one way or the other, I just prefer facts. And the way I read up on it, Bill Gates actually wanted to have as much memory for user space as possible, whereas IBM, who created the original IBM PC, wanted to do it far more pragmatically and wanted to make it an even split, 512 kilobytes for user and 512 kilobytes for system use. And as I understand it, Bill Gates wanted it at around 768 kilobytes or more for user space. He wanted less for the system space. So, as a compromise, the midway point between 512 and 768 is, well, that's 256 kilobytes divided by 2 is 128. So add 512 and 128 and you get the 640. That's where the 640K limit comes from as a compromise. And of course, ideally, we want to free up as much of that conventional memory as possible so that we can run our programs, especially later DOS programs that take larger and larger amounts of memory. And then along comes EMS, the expanded memory specification. This was an attempt to allow those larger applications that needed more storage space to be able to store data in expanded memory and extra memory. And since the original IBM PC only had a 1 megabyte address limit with 640K accessible to the user, EMS was an attempt to map in and out portions of memory that were on the side or above and beyond the 1 meg in what was known as a page frame. Page frame is typically 64 kilobytes divided up into 16K chunks that are accessible in 16K chunks. And this worked for a while. It was a little slow, but it was better than being constrained by the original 640K. Program writers could write their applications to be EMS aware and take advantage of the extra storage space. You couldn't store executable code in expanded memory, but you could store data into that extra memory space, allowing you to use more of the 640K for executable space. And like I said, that worked for a while. Then along comes the 286 and eventually the 386. It was particularly the 386 that had a built-in memory management unit. And this allowed the system to map memory into that system address space between 640 and 1 meg, the 384 kilobytes we all know as the upper memory. This memory is normally not accessible by user programs, at least certainly not on a 286, unless you have a special chipset that has a built-in memory management unit with a special driver that enables this functionality. But the upper memory could then be used to load programs high, to continuously free up more of that conventional memory as users kept using more and more of that user address space for larger applications. And then finally, we come to extended memory. And this is pretty much any memory on a 286 or higher that's above the 1 meg limit. And there was some confusion that I thought I might help clear up that some people were unaware of in like the DOS 5 mem command, or even I think it's shown in the Windows NT DOS box. If you do a mem command, it talks about contiguous extended memory. Getting my words mixed up. It talks about contiguous extended memory, and it talks about XMS memory. And the difference here is that you could think of it this way. Anything that is not controlled by the XMS manager, the XMS memory manager, was pretty much raw extended memory. And anything that was in control by the XMS memory manager that could be used as XMS or the extended memory specification driver and XMS aware applications. Similarly to expanded memory, it allowed XMS aware applications to store data in extended memory instead of expanded memory. You didn't need a page frame now. You didn't have to consume 64 kilobytes of RAM just to swap memory in and out of the usable address space so that it was addressable. Extended memory, as long as you're on a 286, was directly accessible as XMS if you had an XMS-aware application. And an example of this would be like Wolfenstein 3D. When you start up, it shows you bars on conventional memory, EMS memory, and XMS memory. It'll use any or all three for the program to run. It doesn't have to have EMS, it doesn't have to have XMS, but it prefers to have one or the other so that it can run smoothly, and it uses either for data storage space. And Windows is another perfect example of an XMS-aware application. At least the version 3 series and later is actually nothing more than a DOS extender loaded into XMS memory. And then, of course, applications can run from there in protected mode. And speaking of protected mode, that's exactly what happens when you load a memory manager, like an XMS manager and or EMS manager. What actually happens is as soon as that driver is loaded, the system is switched to protected mode, but it still runs everything in what's known as a virtual 86 or V86 mode. So essentially the entire 8086 is virtualized so that you can continue to run your DOS applications, but you are indeed running in a protected mode environment. You don't have all the benefits of protected mode. You don't have necessarily, the memory protection scheme, but you do have the advantage of having access to more than 1 megabyte of memory. So, without further ado, let's take a little bit closer of a look at the different types of memory managers that were commonly in use. And of course, that's way too much for one screen. Oh, and I'm running PC-DOS, so edit doesn't work. So here we go. I have my 3 menu items. I run HiMem and EMM 386, QEMM version 9, and NetRoom version 3.03. And one of the interesting things about NetRoom is that it actually comes with a DPI manager. This was a DOS protected mode interface specification that came out later. Very few applications actually used it. Some did. And in general, you didn't need the DPMI driver to run any of your applications. It was just a nice to have. It was used by development applications. And interesting note, it's also used by PKZip. If it detects that a DPMI manager is installed, it'll be able to run code in 32-bit protected mode. You'll notice that on, say, PKZip 2.04G or 2.50, the last version for DOS. It'll say what it detects, what CPU it detects, what memory it detects, and it'll show you that if you have a DPMI memory manager installed, it'll use 32-bit mode. And if you don't have a DPMI manager installed, it backs down to 16-bit mode. Now, NetRoom. memory manager actually comes with its own stack driver. So that's why I've disabled DOS stacks and I'm loading the Netroom stack driver. It works exactly the same, but according to Netroom, they're faster, up to 30%. Don't know how true that is, never actually benchmark it, but use it anyways. Now, Netroom does indeed have a DPMI manager, but it seems to have some compatibility issues as far as I can tell. I've noticed that when I tried to run certain DPMI-aware applications, it would just simply crash. So kind of an interesting point there. But it should also be noted that if you're running QEMM, so that we're getting all the information out there, is that it attempts to free up more memory through what it calls stealth mode. You could have stealth frame, where it maps your system ROM and your video ROM into the page frame to try to free up more upper memory space. Or it uses stealth mapping, where it maps your system BIOS and your video BIOS into, if I remember correctly, into expanded memory. And it sets the default page frame directly to the C1000 or C000 memory location, which is normally where the start of your video memory. And that can cause some problems if you're using applications that want to directly access the video BIOS, for example, and it does so through that memory location. It won't find it there because it's been stealthily moved out by QuarterDeck. So there could be some compatibility issues there too, something to watch out for. And one last piece before I reboot and show off some of the different pieces. As a bonus to using Netroom, they developed a technology called cloaking. This was a competitor to QEMM's stealth mode. Cloaking allowed Netroom to, instead of remapping your video in system BIOS into expanded memory, it would actually remap it into extended memory, which in my opinion is slightly better. But you can still use applications as you normally would, and it would map all BIOS calls directly back and forth between extended memory and the upper memory block that it's supposed to exist at. And not only would it do this for your video and system BIOS, which, by the way, I don't have the drivers loaded. They actually have two different drivers that you have to load in your config sys to take advantage of the BIOS and video remapping. I've often found that to be very problematic, so I don't use it. But what I do like about the cloaking technology is that any cloaking-aware application can leave a very small stub in conventional memory or upper memory, as low as, I believe, 10 kilobytes, and it will load the rest all up into extended memory. And Netroom provided a couple of their own utilities as an example. So, for example, they have a RAM disk that can be loaded in as little as 10 kilobytes. They have a disk cache that runs in extended memory with as little as 10 kilobytes. And that's something I want to highlight when I reboot the machine, is how much space Smart Drive, and I'm even loading Ncache 2 from Norton Utilities version 8, all as examples. But also, Logitech released a mouse driver that was cloaking aware, and if you loaded Netroom, it automatically supports cloaking. At least this particular version does, and it could move mouse driver up into extended memory using as little as 10 kilobytes. So very advantageous to take advantage of these technologies offered by different memory managers. Now, of course, the one fail that all of these had was at least in QuarterDeck's case, they insisted on centering everything around expanded memory, which was going away. It was an old standard, and extended memory was the way to go. And QuarterDeck had spent so much development time around making their tools use expanded memory that I think they were ill prepared for the switch. And then, of course, along comes Windows 95 and makes memory management pretty much a thing of the past, even though it is still using HiMem and EMM 386. But real quick, let's also take a look at my AutoExec.bat for those caching programs, because I wanted to show them. So in the HiMem configuration profile, I load SmartDrive with write caching, because I don't mind write caching. It's only a gaming machine. I'm not worried about losing data. And I load a large 4 meg cache drive and only use 128 kilobytes when running Windows, because Windows 3.11 has its own vCache driver and you don't need a real mode cache to run. And Windows 3.11 is supposed to detect the DOS cache and disable it and use its own, but that's not necessarily the case. I did test that in, for example, Encache 2 and even Netroom's Cache Cloak, the cloaking disk utility, will still consume all the memory unless you set a Windows size. Now, I'm told, or at least in my studies, I found out that SmartDrive is only efficient up to a 2 megabyte disk cache. Microsoft says anything larger than 2 megabytes is a waste. They pretty much felt that 2 megabytes was more than enough, especially in the DOS days, where between 4 and 8 megabytes of RAM was the norm. You didn't really need anything larger than that. But I chose to go ahead and load a large 4 megabyte cache anyways. Same thing here with Encache 2. I'm loading actually an 8 megabyte cache. Encache 2, or the Norton Disk Cache, claims to be up to 50% faster and more efficient than the DOS SmartDrive cache. So I don't know if that's entirely true. It does feel faster, I'll give it that. When I run Encache 2, I can tell that it feels more efficient, and it's efficient up to 8 megabytes instead of the 2 megabytes from SmartDrive. And Cache Cloak, I don't know if it has a limit or not. I've tested, and it feels like a standard disk cache, almost as good as SmartDrive. But back to, it's got that great feature of supporting cloaking technology, and it can actually run most of the code in extended memory. So very awesome there. So let's go ahead and reboot the system, and let's take a look at all 3 memory managers and the disk caches. I am loaded under QEMM right now, and QEMM has a fast reboot, or a quick boot feature that will trap the Control-Alt-Delete process, skip the power on self-test, and jump you right back into the DOS startup routine. So we'll go ahead and load HiMem and EMM 386 first. And so here we have 640 kilobytes total, 20 kilobytes used, free 620 kilobytes. That's actually pretty decent. And this is all hand optimized. I don't run the MemMaker that came with DOS 6.22. Of course, we're on PC DOS, so it would be RAM Boost under DOS, DOS 7, PC DOS. I don't run the QuarterDeck optimized program, and I don't run the Netroom customized program. I have before. They do a great job. I just prefer to hand optimize all my loading of applications, because I like to play around with different TSRs, and I hate having to run those programs every time I switch out a TSR. Terminate and stay resident, for those that don't know. But let's take a look at the memory usage. As we can see here, the SmartDrive disk cache uses a whopping 32 kilobytes of memory for a 4 meg cache. Now that drops down to about 28 kilobytes if you're doing a 2 megabyte cache, so you do save some there of the management overhead. But that's what you're looking at, 32 kilobytes. So now let's reboot and let's take a look at the QuarterDeck option. So we will go ahead and load QEMM version 9. I still prefer calling it QEM. I don't know why. And as you can see here, slightly in the background, Encache 2 with an 8 megabyte cache. I'll wait until this finishes up so you can see what I'm talking about. Uses a whopping 53 kilobytes of memory management. It does indeed have it all loaded high because I have enough loaded, but that's a lot of high DOS memory to be using for a TSR. Let's go ahead and look at that. So as you can see here, the mem output, you got like 3 different entries. You got Encache 2, Encache 22, and Encache 2 here. I'm not particularly sure why they load 3 different times, 3 different ways. Maybe to get the most out of upper memory blocks. I don't know. I could see it being advantageous if you have fragmented upper memory. But yeah, I don't know. But let's look at this. 640K total, 17K used. So even with the more the larger disk cache, we're only using 17K as opposed to 20K, leaving 623 kilobytes free. Now you'll notice that my upper memory is using almost 200 kilobytes of the 384K because I am using the stealth mapping technology, and that allows Quarterdeck to swap in and out the video BIOS and system BIOS. We can take a quick look here with Quarterdeck's Manifest program. Yeah, as you can see here, I think this shows it. The C1000 to C0FF is a 4K stub of ROM, while C100 and C7 through C7FF is all high RAM. And then C800 to C7F is another 2K of ROM. So it's pretty much mapped out the video ROM there. And then, of course, here's the system ROM taking up as little as 1.4K of system space, and it's turned a lot of that into high RAM. And then, of course, there's the page frame there at EC100. So it provides a lot of upper memory as long as your system is compatible with those options. And it's actually recommended to use stealth mapping over stealth frame, but for compatibility reasons, stealth frame should be your second choice if you're having problems with mapping. So that's QEMM and Encache 2. Now let's reboot again, and we'll get the Quarterdeck Quick Boot. And let's load NetRoom, the NetRoom memory manager, the Helix RAM manager. As you can see there, I do have that 8 megabyte of cache, or 8 megabytes of memory set aside for caching. I did enable write caching too, because I think write caching really helps performance. But now let's take a look at all the upper memory blocks. As you can see here, Stack's driver has been loaded high, uses only 3K, and Cache Cloak only uses 10 kilobytes of memory for an 8 megabyte cache. So you can consume a large, or you can have a large disk cache to really help out your performance if you have the memory to spare. And consume a very little amount of memory. The NetRoom Memory Manager is pretty cool for this. So yeah, now it only uses 1K more than the Quarterdeck, 640K total, 18K free, 622, 18K used. Getting myself all mixed up. And I only have 124 kilobytes of upper memory total that is usable for UMBs or upper memory blocks. And I'm only using 90 kilobytes. So as you can see, it's all relative. It doesn't matter if you have a large amount or a small amount, as long as you can fit as much as you can into that upper memory space. It really seems to work out well. So that's the 3 memory managers, the 3 most popular ones. I know there's the RAM Manager 386, or 386 to the max, I believe it's what it was actually called. I have that. I don't have it installed in this system. It looks like it was just recently released as freeware, and they're hoping to include it in FreeDOS for those of you who care. So I think that's pretty cool. But this was just, yeah, just a little quick overview on DOS memory, the different types, the ways you can look at them, how you can configure your system. If you have any questions, feel free to ask down in the comments below, or any corrections. Please, by all means, comment below and give me corrections. I'm always willing to learn. Anyways, that's it for this video. Thank you very much, and I hope you found this informative.